Greetings everyone, I am Diane and today I will be enlightening everyone about the photoelectric effect. So, what is photoelectric effect? When an incoming radiation or light in the form of photons with the right threshold frequency hits a metal surface, it will emit electrons known as photoelectrons. Basically, that is the whole process that explains the photoelectric effect. Next, the experiment on photoelectric effect. In 1887, Heinrich Hertz was conducting an experiment to prove Maxwell's theory of electromagnetism when he found a tiny spark at the receiver but was not sure what it was. He then later confirms that it is the photoelectric effect. In Hertz's experiment, he saw a bright spark with the UV light at the receiver of his experiment setup. However, when the UV light is blocked, the spark seems dim. Later on, in 1899, J.J. Thomson established that UV light caused electrons to be emitted, which explained the sparks in Hertz's experiment. In 1902, Philipp Lenard, who is the assistant of Heinrich Hertz, conducted an experiment and found that the intensity of light is not a factor of the amount of electrons ejected. Robert Millikan then made further research and found that the light must reach a minimum threshold frequency, which varies with different metal, for the electrons to eject. So, it doesn't mean that when a light has large intensity, it can eject more amount of electrons. Robert Millikan just confirms Philipp Lenard's conclusion that the intensity of light is not a factor of the amount of electrons ejected. Last but not least, let's take a look on the implication that the photoelectric effect brings to today's modern physics. First is the discovery. In 1905, Albert Einstein discovers that light behave as tiny particles known as quanta or photons. He also states that energy of each tiny particle was proportional to the frequency it was part of. He then came up with an equation, E equals to hf minus w, where E is the energy of each tiny particle, h is the Planck constant, f is the frequency of the light, and w is the work function. Since photons has no mass but has momentum, it can hit an electron and knock it out of the atom, disappearing in the process and giving all its energy to the electrons. Next, let's take a look on the applications of photoelectric effect to humans' daily life. Did you guys know that the solar cells uses photoelectric effect to function? Yes, it does. And so does night vision device, which are used widely among soldiers. So does photomultiplier and gold leaf electroscope. In all, photoelectric effect has brought many applications to humans' daily life and made life easier for us. That is all from me. Thank you for your time, and I hope you guys gain insights from the video and share your knowledge with your friends and family. Thanks once again.